Select the statement that best describes the reaction below at equilibrium. And what we have here is we have an acid-base equilibrium, and we can see that by noticing that it is protons that are being moved around, H+. So we can see that we have this nitrogen with a negative charge that is gaining a hydrogen, and we have this alcohol, this OH, that is losing a hydrogen. So seeing that, Q tells us that we have an acid-base equilibrium. And we know that when an acid-base reaction reaches equilibrium, you will have the greater concentration of the weaker acid and the weaker base. And so we say that acid-base equilibria favors the weaker acid and the weaker base. So that means weaker base and weaker acid. So that means that you would have a greater concentration of your weaker acid and your weaker base at equilibrium. And so if we had something like a Ka value for our acids or a pKa value, then we could compare. In this case, we have the structures, so we need to analyze the structures. So the first thing we should probably do is label the role that everything is playing in this reaction. So we can see that it is the propanol that is losing H+. That means the propanol is acting as an acid. And we see that this negatively charged nitrogen is gaining a proton. So that means that this is acting as the base. And so then we can also carry through and label the conjugate acid and the conjugate base. So after the propanol loses that proton and becomes this oxygen anion, that is the conjugate base. And after our negatively charged nitrogen gains a hydrogen, then this is your conjugate acid. And so what we have to compare here in the structure is the difference in where the acidic hydrogen is located, the atom that it is on. So we are comparing a hydrogen that is attached to oxygen to a hydrogen that is attached to nitrogen. And so the general trend that we have for determining acidity based on structure is we can use this acronym CARDIO. And we've written this out in another video. So the C is for charge. So if one of these had a positive charge, it'd be the stronger acid. The A is for atom. So this is if your acidic hydrogens are attached to different atoms, we can predict the relative acidity by looking at what those atoms are. And so we have oxygen and we have nitrogen. And those are in the same row of the periodic table. So in that second row of the periodic table, we have carbon, nitrogen, oxygen, fluorine. And so as the electronegativity increases, the acidity also increases. So what that means for this scenario is it tells us that the hydrogen attached to oxygen is the stronger acid. And then the hydrogen attached to the nitrogen must be the weaker acid. And so this equilibrium is going to favor the formation of the products because this is where you have your weaker acid and your weaker base. If propanol is the stronger acid, that means its conjugate base is definitely the weaker base. Okay. And the reverse is also true. If this is your weaker acid, its conjugate base is the stronger base. So we see with this relationship that the weaker acid and weaker base are always on the same side of the equilibrium. The stronger acid and stronger base are always on the same side of the equilibrium. So we really didn't need to label these. We could have stopped as soon as we had labeled our stronger acid and weaker acid. So we see that we're going to favor product formation, and that is because this propanol is the stronger acid. And so that is A. The reaction favors the products at equilibrium because propanol is a stronger acid than 1-propanamine.